Good evening, sir. My name is A. Pooja Lekana. Now I am going to tell about the understanding Zener diode and breakdown mechanism and applications and their usage. The first one is introduction of the Zener diodes. Zener diodes are special type of semiconductor diodes designed to operate in the reverse breakdown region. Unlike standard diodes that are typically damaged by reverse breakdown, Zener diodes are energy to with understand this condition and maintain a suitable voltage across their terminals. This characteristics makes them invaluable in various voltage regulation and protection circuits. This is the Zener diode characteristic function. Zener diode structural and symbol. A Zener diode is a heavily doped in PN junction diode. The heavy doping results in a narrow depletion region. The symbol for the Zener diode is similar to that the standard diode but with bent ends on the cathode bar, disi- distinguishing it from a regular diode. Breakdown mechanism. Two primary breakdown mechanisms can occur in a reverse bias diode. There are Zener breakdown and avalanche breakdown. These two breakdowns mechanism occurs in a reverse bias diode. Zener breakdown occurs at a low reverse voltage characterized by tunneling of charge carriers. Avalanche breakdown occurs at the high reference voltage involves of the multiplication of the carriers through. First one is Zener breakdown mechanism. Zener breakdown occurs in a highly doped PN junction with a narrow depletion region. The strong electric field in a depletion region can directly break covalent bonds, generating electric hole pairs. These carriers are accelerated by the electric field, resulting in a large reverse current. Voltage dependence. Zener breakdown typically occurs at the low reverse voltage, typically below 5 volts. The temperature coefficient. Zener breakdown has a negative temperature coefficient. As temperature increases, the Zener voltage decreases slightly. This is the Zener breakdown mechanism. And the avalanche breakdown mechanism. Avalanche breakdown occurs in a lightly doped PN junctions with a wider depletion region. When reverse voltage is applied, minority carriers gain kinetic energy as they accelerate through the depletion region. If the voltage is high enough, these carriers collide with atoms in a crystal lattice, ionizing them and creating new electron hole pairs. These newly generated carriers also accelerate and collide with other atoms, creating an avalanche effect of rapid increasing current. Voltage dependence. Avalanche breakdown typically occurs at the high reverse, typically above 5 volts. This is the avalanche breakdown process. Both Zener and the avalanche breakdown can occur in the Zener diode, but the Zener effect dominates at the low voltage while the avalanche effect becomes more significant at a higher voltage. Diodes designed to operate at the voltages around 5 volts often exhibits a combination of both effects. The next one, Zener diode breakdown effects. Reverse breakdown voltage. It means VZ. This is the key parameter of your Zener diode. It is specific reverse voltage at which the diode begins to conduct significantly in the reverse direction. Zener impedance means ZZ. This is the dynamic resistance of the Zener diode in the breakdown region. It represents the change in the voltage for a given change in a current. A lower Zener impedance indicates a more suitable voltage regulation. Maximum power dissipation. This is the maximum power that the Zener diode can safely dissipate without being damaged. It is determined by the diodes and current ratings. The temperature coefficient, as mentioned, earlier, Zener diodes have a temperature coefficient that indicates how the Zener voltage changes with temperature. This is the Zener diode parameters. First one is Zener impedance, second one is reverse breakdown voltage, third one is maximum power dissipation, PZ max. The fourth one is temperature coefficient. Advantages of the Zener diode: simple and inexpensive. Means Zener diodes are relatively simple and inexpensive components. Stable voltages regulations. They provide a stable voltage regulation over a wide range of input voltage and load current variation. Fast response time. Zener diode has a fast response time, making them suitable for the applications requiring quick voltage clamping. The next one is Zener diode limitation. There are three limitations of the Zener diode. The first one is Zener impedance. Voltage variations occurs with the current changes due to the impedance. And the next one is temperature sensitivity. Zener voltage changes with temperature affecting accuracy. Limited power handling. Zener diodes cannot handle high power levels. And the conclusion: Zener diodes are essentially components in many electronic circuits, providing a simple and effective way to regulate voltage and protect sensitive components from the over voltage conditions. Understanding their breakdown mechanism, characteristic, and applications in a crucial for designing reliable and efficient electronic system. Well, they have limitation, their advantages often outweigh the drawbacks, making them a valuable tool for electronic engineers and hobbyists alike. Thank you, sir.